Hey everyone, welcome back to my YouTube channel. So in this tutorial, I'm trying to discuss about hand number sign recognition and detection using Tensorflow object detection API. So if you are new in my YouTube channel, so please do subscribe my channel and must hit the bell icon because in every week and daily basis, I upload some videos regarding machine learning, data science, artificial intelligence, and so on. So in this tutorial, I'm trying to discuss about this topic. So you can see here I uploaded some videos regarding deep learning, so face mask detections, and some videos regarding natural language processing. Okay, so check out all my videos if possible. So let's jump on our actual project. So first, what you need to do, you need to install TensorFlow object detection API. So I recommended to following the Keras sir YouTube channel. So he actually made a playlist for a TensorFlow object detection API installations in your local machines. So you can also follow this. So first thing first, you need to install this. Go to this URL and you need to copy this whole path. Okay. So you can just click on here. If you have a Git in your local machines, you can also copy this and clone your GitHub clone this repository in your local machines folders, and you can also download these files and GitHub files in a zip format. Okay, so I already download this and also install this TensorFlow object detection API. So you can see here, this is the Keras sir. Thank you sir to making this call playlist. Even though I also follow this to install this TensorFlow object detection API in my local machines, you can also follow this channel Keras sir. So to install this object detection API. Okay, so after installing this, you can find here like that. Okay, so this folder, when you clone this repository, okay, you can find here a models files look like that. So after installing all these things, so you need to do. So you can see here research folder. You need to go with the object detection folder. So this is your working directory. Okay. So now first you need to collect the data. So in my face mask detection video, okay, this is the face mask detections. So I already discussed about how can you collect the data because this video is so long. You can also follow this. So to collect the data, so I already done this. Okay, so you can see here I already done this in my collect.img. So you can see here I collect all the images for number sign 1, 2, 3, 4, and 5. So now we are going to use a exe file, okay, to label our image. So this is the URL for that. So label img. So you need to just click on here to download this exe file. So I am not going to save that because I already do that. So if I go here, so you can see here this file. Okay, how I extract these files, you can find here look like that. So label img is a applications. So make sure that you install Python in your local machines, otherwise it doesn't work. So maybe, and also you need to install PyQ5 in your local machines. Just open your command prompt and type pip install PyQ5. Pip install PyQ5. So you need to install this PyQ5 in your local machines. This is actually a GUI framework in Python. So there are so many GUI framework like Tkinter, KB, PyQ5, and PySite also. So I'm going to close this. So you need to just click on here to double click to open this label img file. So you need to just click on the open. Okay, or let's say open the dir. Open dir. So I'm going to go here. Maybe this one is the collect image. Okay, maybe collect image. So inside this maybe files. So that, where is the files? Yes, these files. Collect image. I'm going to select the folder. So you can see here this is already done by me. Okay, I think this is not what collect image. Okay, this is already done by me for some reason. Delete. Okay, I am going to also delete it. So you can find here like look like that because I already done the leveling before. So that's why it will give me look like that. So just you need to click on here to create a rectangle and just select, okay, and type here the label. So you can see here I type here the 3. So just go okay, and again create a rectangle and select this and okay. So you can see it is done, and just you need to go up here and the save. So after saving this, you need to also change the save path. So you just click on here. I'm going to go here. So these files, just select this and going to save that. Okay, so go here, you can see here the files. Okay, so if I going to click that, this is the XML file. So I think I need to open this file using the Visual Studio Code. Okay, so you can see here all the annotations, information is given here, white, height, and the file path, and also the xmin, ymin, ymax. So just you need to collect the data. After collecting the data, you need to annotate it. Okay, after labeling all the files, you can find here a look like that. I'm going to close that. You can find here the images is actually, this is not, maybe this is okay. Go here, maybe this one. So after that, when you label all the images, you can find here this like file and also the class names. So these are also class names, dog, person, cat. It's already done. So just you need to delete all the files just like that. So you can say 5, 1, 3, 4, and 2. You need to save this. Okay. So you can see here these all the file with respect to the labeling. So after labeling all this file, so what we need to do, we need to divide our data set into train and the test. So I already do this in my files. You can see here 80% of the training folder. So inside this you can see a training folder with respect to the XML file and the pictures, and also in the test you can see here all the files of that. Okay, so I put here the 20% data in the test and the 80% data in the train. So you can say class dot names. So now you need to actually make a text document, and you can see here if I go here and this one the images, you can see here this is the classes. Okay, so you need to create another a text document name as what do you call, name as class underscore names. So in this you can see here all the classes is given here. So I'm going to close that. So I'm going to copy this folder, cut, okay, not copy, and go to this TensorFlow 2.2.0. Go here, models, go to the research, go to the object detection and paste it here. Paste. Okay, so you can see here this folder is pasted here. Okay, if I go here, maybe this one should be images. So now we need to generate the train, test, XML and CSV file, and also the TF record file, also the labelment.pbtxt file. Okay, so I'm going to go my files. I already do that. Files, I'm going to copy this Python file. Okay, copy or cut, and go to this file. You can see pinned, already pinned, and go to the research and go to the object detections and paste it here. Okay, so then go to the files and you can see here the steps. So run this command for generating CSV file for the training and the testing. So you need to copy this one, Control C, copy, and go to the TensorFlow 2.0 and go to this one and also the object detections and just type your CMD and this one. So it will help you to generate the XML to CSV file, and it will be saved in your images, maybe images. Yep, you can see a train level and the test level. If I go here and click this, it will generate Excel file. So it will opening my Excel already done. So you can see here the file name, the width and the height and the classes, and the xmin, ymin, xmax and the ymax. So you can see here in the XML file. So it will just generate this XML file into the CSV file. So it is also same as the train test. So now you need to generate the labels, label XML. So just go here and you can see run this command to generate the label map.pbtxt file. So I'm going to copy this Control C, and go here and paste it. So it is done. So check it out here. Go you can see a label map dot pbtxt file. Okay. So now we need to generate the TF record file. Just you need to copy this command, Control C. Make sure that your URL should be same. Just inside this object detection folder in this resource. You can see a path is already given here. So it will take some time. You can see here successfully opening the dynamic link library. So I am using NVIDIA GeForce GPU and maybe MX230. Okay. In your case, it's takes a few amounts of time because mine support and also my GPUs. So also we need to generate for the test. Okay, so go here and also then paste. Yep. So it will generate the trained.record file. So this is the TF record file. So you can see here, if I go here, okay, so you can see here trained record and the test record. Okay, so now we are going to use a pre-trained model. Okay, what you call pre-trained model. So we're going to use efficient. Okay, I'm going to close this, open a new tab and type your object detections model Joe, and you can see here this link. Just click on here. So we are going to use efficient dat D0 and 515. Just click on here. So it will download this Kako file. So I already download this and also extract this file. So we're going to use this. So I'm going to remove that and go to these files. So you can see here efficient D0 and Kako 17 TPU 3T. So this is the file for efficient. So I'm going to copy this or cut and go to this Tensorflow 2.20 and go here and go to the resource file and go to the object directions and paste it here. Okay, so this is the model, is pre-trained model we are going to use and also customize this. So if I go here, you can see here the checkpoint and the save model. So you can see here some assets is actually empty, variables is also contains some folder, and also save model. This is also a PV file. So if I go here, it's a checkpoint. Okay, and this one is the pipeline. So just you need to go to the configs file and you can see here configuration file for the efficient D0. Okay, if I find here, you can see SSD efficient D0 512 512. So you need to copy that, copy, and you need to go to your images and paste it here. And now you need to do some editing on that. So you can see here, this is the SSD mobile coconut. It's already done by 19 classes. So you need to just change the number of the classes and the number of the path. So you can see here, so huge line. So you can see a path to be configured for the label map.txt file, and you can see a path to be configured label map.pbtxt file, and path to be configured train of the TF record file. So you need to put here all the path of the TF record and the labels file. So I already done that. Okay, if I go here, I'm going to delete that, go to the files, and you can see here this is the aesthetic of it. Cut and go to this and go and resource and object directions and go to the images and paste it here. So don't worry on that, I explain all the thing here. Open the code. Okay, this is not, yep, okay. So you can see a number of classes 5 because you have 5 number of classes, 1 2 3 4 and the 5. So if I go down, okay, and you can see here, just a while. So you can see here fine tune checkpoint. Okay, if I go here, you can see here fine tune checkpoint. Just copy this line and paste it here. I already done it. And for fine-tune checkpoint type detections, so because you can see a fine-tune checkpoint type is right now detections, so in your case it will be recognized. So I already editing these files, so just you need to do some changes on that. So you can say detections, so don't worry, I'll give this notepad in your in my description link. So you need to do some changes on the learning rate 0.001. you need to do some changes, so I already do that. So don't worry, I also put this SSD efficient D0 512 cross 512 Coco file in my GitHub repository and also my drive link. So make sure that my path and your path should be same. So images and label map.pbdx file, you can say label map file, and also this one. You can do changes by own, or you can also copy this one. So it's so easy, just you need to put the path. So I'm going to close that, also this one. So our work is right now done. So now we need to move on that training. Okay, so you need to go and copy this one, also the label map file, just copy and creating another folder called training, new, and this one train. Okay, so just go here and paste this one, and also you need to create another folder called object detections. Okay, you need to just copy all this file and expect training, and this one copy and go to the object detection and paste it here. So it will take some time, maybe a while. Okay, iterative actions, I am going to skip this. Okay, yes, done. So you can see here it's already done. Okay, so now we need to start our training. So our efficient files is done, our images is also fine, our level map is also fine. So now we need to go here. You can see here training your model, just copy this command and go here, just paste cmd and this one. So you can also use a Google Colab to train you this model. Sometimes in local machines your computer should be lagging, because make sure that it will load your machine so times. So in my case I am using Core i5 and 8 GB RAM and NVIDIA GeForce MX230. So I think it will work fine in my case. So you can see here it will take some time, maybe 2 to 3 hours to train your model. So I will train my model in my local machines, and after you can see here, you can see the input and the output. Okay, like that. So it will maybe take so many times to train that, maybe 2 to 3 hours. So I already done that, so I am not going to train my model again. So after that, when you train your model, your training is completed. Maybe your loss is maybe accuracy is like greater than 90. You can also close that. So after closing this, you need to create a graph, inference graph. Okay, if I go here, you can see here this is the export the inference graph command. So after model's training is done, you need to export this model. So just you need to copy this link or path and just you need to paste on here. Okay, after the model or how do you call training is completed, so you need to just paste on this and it will generate an inference graph. Okay, so after generating the inference graph, inside this you can find here checkpoint and the saved model. So this is your actual model. So if you getting so confusion, so comment below. I think it will done in your case. You can also use Google Colab to actually train your model. It's also same, just you need to do some changes on that. So okay, I am going to go these files. You can see here the inference graph is already done by me. So I'm going to cut that and go here and Tensorflow 2.2 models research and the object detections. I'm going to pass that. So don't be confused on that. Just when you actually train your model and after training is completed, you need to just export your model. That's mean inference graph. So just you need to go in this path and just type this command. Okay, so don't be confused. You can also use Google Colab. Okay, you can also use Google Colab to actually train your model. So I'm going to minimize that. So you go to inference graph. Inside this you can see here checkpoint in the same model. So this inference graph is actually for the custom of the detections. So if I go here, okay, check here, this is the actual model. This is already trained, pre-trained, but in inference graph this model is trained by me. That's been for the custom data, because in efficient T0 Coco is already trained the 19 number of the classes. Okay, so now you need to go here and copy this one for testing our models is working fine or not. So I'm going to go here and this one, go models, resource, and go to the object detections. Okay, and not object detection, inside this folder test. So now we need to open this object detections underscore test.ipnv file. So I'm going to cmd, type cmd and type Jupyter notebook, pyt or Jupyter notebook. So it will opening this Jupyter notebook in my local host. Okay, so this is the code for that. You need to do some changes on that. You can see here code. Okay, so now you need to set up something on our case. Make sure that your internet should be connected. So you need to install this TF Slim. Just shift enter and install the PyCoco tools. Make sure that it's already installed. Maybe you can install when you install this object detection API in your local machines. You can see your requirement is already satisfied. So when you're trying to install some library, you need to put here this exclamation sign in Jupyter notebook. So past and this one, just you need to shift enter because code is already done by me, and maybe it will take some time to actually loading all the files. Yep, this one. Yep, it's worked fine. So you can see here detection model tf.saved model. So it is loading this inference graph. Inside this inference graph you can see here a saved model. So inside this saved model you can find here, just if I go here and this object detections and inference graph, you can see a saved model. Inside the saved model, this is the pb file for the custom object detections. So it will take some time to actually load that because it is a heavy file, so don't be confused on that. So detection model tf.saved model, and take some time to actually loading that. So now our cell is running fine, and also this one. Okay, so it will opening my camera. Yeah, you can see here camera. So you can see here if I 1, the 2 and the 3 and the 4, this is mine. So you can see here this code is working fine. Okay, 4, 3, 2. Okay, something is called 1, 2, and also 1. This 1 and 2 and the 3, 4 and 5. Yep, this is working fine. So this is the tutorial. Hope you will enjoy this tutorial. Make sure to subscribe my channel and don't forget to hit the bell icon. So if you have any confusion to actually install this Tensorflow object detection API in your local machines, you can feel free to contact me because we have a Facebook page, and also you can also knock me on Instagram. and also my personal Facebook to if you face any problem to install this update editions API. And also if you have some confusions or you don't understand these, so you can also feel free to contact me. So don't worry on that. So thank you so much and bye bye.